Okay, I think we're just going to start right now, if that is okay for everybody. Okay, so a couple of questions before. Who knows what sun.misc.Unsafe is? Okay, who used it before? Wow, that's very unexpected for people listening to that talk, but we'll figure it out. So, who heard about that sun.misc.Unsafe is about to disappear in Java 9? Okay, who heard that it is not going to happen? Wow, okay, now we're speaking. Perfect. So this talk is not about ranting about sun.misc.Unsafe going to disappear, because that is not going to happen anymore, so we're good to go. That is the reason why I chose this nice picture. It actually is post-apocalyptic because it shows a very nice future. So what this talk is all about is selling dreams. Selling what is upcoming in Java, hope most possibly at least. First of all, a bit about me. I'm manager developer relations at Hazelcast, who worked with Hazelcast. Ah, that's nice. So, well, as manager developer relations, you're basically supposed to speak about Hazelcast, but I don't like to. I do this quite a lot, and I thought for this year I need something else to talk about. So, I'm a Twitter fanatic. If you really want to have your timeline bursted, feel free to follow me, otherwise you probably don't want to do that. I'm a Java passionist, and that means for me, I'm part of the JCPEC, so the executive committee that actually drives the Java language. And I think that is quite important because the Java language is still an important thing. It is still growing, the ecosystem is still growing. I think most here are Java developers. Yeah, Java EE developers? Well, that's unexpected for a conference that is called jeeconf. But at the moment, the JCP is mostly concerned about the way Oracle handles the Java EE ecosystem. And I think it's still a big part. I personally not a big fan of Java EE, but I think it's important for the ecosystem to still exist. Apart from all this Java stuff, I'm mostly interested into anything of performance-related, garbage collection, any kind of benchmark fairy tales, because we all know benchmarks are not real. I hope nobody disagrees with that. And that's basically what I am, or who I am. And I already said this talk is not going to be negative. Before, when I created this slide deck, the first question on Twitter was like, are you going to rant again about sun.misc.Unsafe? I was like, no, I don't. So I had this hardcore feeling I really have to put this into a disclaimer. But, and that is the important thing, a lot of this talk is at the moment very speculative, and it doesn't need to come out this way. This is, as I said, it's about selling dreams. At the moment, there is almost nothing which is real about this. So the main idea is trying to make the unsafe stuff safe and exchanging all the unsafe APIs with, well, most of the unsafe APIs with something cool. Something which is not running with scissors anymore, at least. So what you probably know or don't know about unsafe. So who knows what unsafe was made for? Okay, so it was an internal class, and it was used inside the JRE. That is what it is designed. Well, that is what it is designed for. That, by the way, is a bit of the for join pool. Who knows Stuckley's kind of code style? He's the developer of most of the concurrency API, and that is what the API looks like internally. Pretty impressive stuff, and most of the time you have a hard time understanding it. But there are some use cases outside of the JVM. They were never expected to happen, or they were not supposed to happen, but they did happen. One of those things is deserialization. We see this example in a bit again. Deserialization, in this case, unsafe allocate instance, creates an object instance without executing any kind of constructor. If I deserialize something from byte stream, I don't want to have the constructor being executed. But there is, and that is the big problem with unsafe, there's a lot of stuff which is not supposed to happen. So at the JVM LS, the JVM Language Summit, Mark Reynolds last year found like the perfect example of what you don't want to do. So he figured out, or he found this Stack Overflow post, and we all know Stack Overflow is awesome, right? So somebody asked, how do I free the object's memory in Java using unsafe? And he had a great idea. Maybe I could use the hash code Who believes that the hash code will give you the object's memory address? Ah, there were 2 hands, no. Perfect. So what actually happens is you get a segfault. And that is going to happen in like 99.9% of the cases. I just chose an example. I wrote to memory address 0. So that is, I just made it consistent. So this is consistently failing. Very easy. So as I said, there are a couple of very bad use cases people try to use. As I said, never intended for outside use. And I think Sun at that time made it clear pretty early in the time, right? This is Wayback Machine. I think everybody knows that. And it goes back to, so that is the oldest entry in the Wayback Machine. It's 15th February 98. Well, Java developers are not supposed or should not call anything inside the Sun packages. Well, yes, they might be right. But there's quite a few popular libraries using unsafe for one use case or the other. And I just try to capture some of those. Unfortunately, I haven't had more space on the slide. And well, so who uses Netty? Mockito, JMock, Cassandra, Hazelcast, Spring. Well, you're pretty much, well, in bad shape for at least Java 10 then. We know that we saved Java 9, but Java 10 is still upcoming, somewhere in 2050 maybe. So the second claim that I often heard last year is sun.misc.Unsafe is not important because it's only supported by the hotspot JVM. I'm not sure. Does anybody know that claim? Well, if you work in this space, you hear this a lot. And it's kind of not true, unfortunately. I just walked through the different JVM implementations I could find. There are 5 that don't implement sun.misc.Unsafe. One of those is, by the way, the amazing Bika VM, which is a JavaScript-based JVM. Don't use that. It works. It actually runs Java inside of your browser, based on a JavaScript-based JVM, right? There are 2 Java-based operating systems. Both of them are kind of, here we go. Kind of not in development anymore, but even though those 2 things had sun.misc.Unsafe, because it's just so important. And there is IKVM. Who knows what IKVM is? Right. So what it is a .NET implementation of the JVM. So you can run Java code on top of the CLR. And even that one has sun.misc.Unsafe. For all the reasons we just saw that pretty much every framework uses it some way or the other. So as said, there are a couple of good use cases. One of this is low latency and GC overhead minimization. You can do this with a flyway object, overly simplified example. You have a base address, you somehow allocate this memory, right? And then you have a very efficient, very decent memory layout of your objects. And you just calculate those offsets starting from your base memory. The second one, we already seen that, is deserialization. It's used in pretty much every deserialization framework for that very reason. 64-bit memory allocation. Who's using more memory than 32-bit at the moment? Well, that's good. Nice. So that is a problem, right? Byte buffers are still 32-bit, and they will never change because the API is just set. Atomic memory operations. Compare and swap. Anybody using atomic X classes? Atomic field updater classes? Okay, wow. You guys will see something new. That's nice. So Unsafe gives you all this compare and swap atomic operations. That's pretty neat. And it actually works inside of field offsets, inside of objects and kind of things. Efficient memory layout, we already had this, right? You have a point class, and you can make sure that it just is what you supposed to be, what it is supposed to be. It's X and Y. You can have fast memory access, field access. So you just have a reflect field. You ask for the field offset. So that is the offset address inside of the object's memory. And you can read and write that. That actually works on final fields as well, same for reflection. And that is very impressive and very important because that is not possible in Java itself. So when you mark an array in Java as volatile, it means that your object, your array itself is volatile, but not the elements inside the array. So that does something which is not possible in Java. You actually get volatile or volatility based on the elements inside of the array, which is very nice, and it's a common use case to actually use it for exactly that reason. Custom memory fences, that was recently introduced in Java 7. You can have memory borders or memory fences inside of your Java code, and you can emit this yourself. So full fence gives you a store and load barrier, and the other ones are just either store or load. That is an implementation detail or a very important thing if you write high frequency or low latency code, because sometimes you don't want to have those full memory barriers that volatile gives you, but you want to emit those barriers yourself. Especially for that reason, when you know, okay, now I just need a write barrier because I'm not going to read it in this thread anymore, but the other thread needs to read it, so he just needs a load barrier. Yeah, and fast interactive with native code. We'll see this in a bit with JNI. So you just allocate some memory, you copy your array content, whatever it is, and then you do a native call. Anybody works with JNI here? Integrating native libraries? Native libraries that use pointers to memory addresses to work on that? This is where this comes in, because the allocate memory returns you an address you can pass to C++ or C code, and that actually works. Okay, so I'm just going over this quickly because we have the examples in a bigger way in a bit. So how do we get access to sun.misc.Unsafe? If you're a JRE or JDK developer, it's fairly easy. There's this nice call. It's a singleton instance. It works pretty well. Unfortunately, that has a test that makes sure that you are inside the JDK, that you are loaded by the Bootstrap class loader. So the version that most libraries use outside the JDK is you get into the sun.unsafe class and you ask for the field the unsafe. You make it accessible because it's a private static final field, and then you just get your unsafe instance. That works on like 50% of the JVMs. For the other cases, there is a working example where you just try to go through all the fields and you try to cast every field to unsafe, and if that works, you found your instance. So that works on Android because the Android developers were smart. They thought, well, we are just preventing people from using unsafe. We don't call the field the unsafe, we call it v1. Right? v1. We know there's only one Highlander and one unsafe, unfortunately. So that works for like 99% of the JVMs. Some JVMs have some weird regulations where you really can't access it, but well, we don't need to figure that out. And then there is one, who knows Charles Nutter, the JRuby guy? One, okay. So he came up with that one. I find this very impressive. It's so easy that it kind of took my heart. You get the default constructor of the unsafe class, which is existing because it's a Java instance, right? It's a Java class. And you create your own unsafe instance using this constructor. I mean, everybody knows singletons in Java are not really existing because you can always create a second instance, right? So he just breaks the singleton pattern. It doesn't matter in this case, though. So the question is, looking at all those codes, does any of this feel right? Most probably not. And this picture is from our restroom at our first office in Palo Alto. So my boss tweeted that, and I was like, where did you find this picture? And I was like, I took it. Where? Right? Like, it actually has two washing places, but just one closable door. So it's very efficient. I don't know. That one is not better though. I know this takes quite a few seconds to realize what this is. Well, okay, so in April last year, Donald posted to the OpenJFX mailing list. OpenJFX is the open source behind JavaFX, and made a statement about the use of sun.misc.Unsafe inside of OpenJFX, because they started like, hey, if that is going to be removed in Java 9, we have a big problem. And I read this and I was like, okay, sun.misc.Unsafe must die in a fire. I read it further and I was like, ignore any kind of theoretical rope, okay. And kill unsafe dead, kill unsafe right? Why did Oracle create a new task force? Like the cat kill unsafe to total death or something? I don't know. So I had this weird feeling. I thought, wow, maybe you should read it again. Maybe there was something important in the sentence, and it actually is, or in the text. If you're using unsafe, this is the year to explain where the API is broken and to get it straight. So he made a point with a lot of blah blah around it. So the question is, what's coming? And here's where the talk actually starts. And we are 17 minutes in time, so that should be fine. These are some examples where sun.misc.Unsafe will replace with some proposed API. And in the end, if we have time, there are some more cool features upcoming. So atomic updates. We already seen this, compare and swap long. This does a check if the old value is still true. It will atomically exchange it with the new value. It might fail and you just retry. That's where the while loop is for. Okay, you can do this with atomic long. I've seen there are quite a few people using atomic long instances. There's just one problem with that. If you use it inside of a record store and you want to store a version field for every record, you make one record object, two objects, because they have an unsafe, an atomic update, atomic long field. So now you have two objects per record. If you not only store a version, but also things like last access, created, and it's getting more and more objects just for a single record, and you don't want to do that. So this is where you use the field updater. A field updater is an object that uses internal reflection and some magic with unsafe, and you just give it the field, and well, then you just say, hey, increment and get, which is the same as compare and swap, what we did manually. And this will do it with one instance, a private static final on all the record instances. That's pretty neat. And by the way, if you do such things, please be humble to your colleagues. Your JVM will tell you this field is never written because it is written through the updater. So please make a comment. Otherwise, somebody just removes it and thinks it's not very important or something. I don't know. So with Java, with the VarHandle API, and that is where the first extension comes in, you get an inlineable native access to fields. That means the JVM is free to handle it in the same way as it would be in native Java code, even though it still looks like reflection. So let's see, we have this VarHandle and a version. You still have just one instance. And the way you get it, anybody worked with method handles so far? Method handles, a couple of people. So method handles is the same thing for methods. It's basically you're creating call sites at runtime, and the JVM is free to inline those call sites. Which means you say, hey, this is my call, and the JVM tells you, well, I don't know what to call at that point. This is where invoke dynamic came in. And then you tell the JVM, well, I know how to bind this, so this is my call, and I want to have that one called. And the JVM says, okay, now I know about it, and whenever I have to inline something, make something shorter, more compact, I can do this for you. And VarHandles goes the same direction. So it looks to the JVM after this bootstrapping like it would be a normal field access right in your Java code. Like you would access this version field directly. And that is a very important point because it makes the JVM way more efficient in optimizing the code at runtime. The next thing is memory access. We're going back to allocate memory, so we're allocating this case 8 bytes. exactly one long object or one long value. We're putting in some value, max value, and we're getting it out. We can do the same thing with byte buffers. We already figured out byte buffers are just 32 bits, so that is still our problem. But we can do this. We'll just allocate 8 bytes, and we write to the byte buffer a long, and we get the long out. There's just one long, so it's index 0. But what is coming up, and that is very interesting, with VarHandles, you can simulate access to a byte buffer in a way that it looks different. So that means I create a view on my byte buffer that makes it look like an array, long array. This is very interesting because I don't have to play around with that anymore. I just say, hey, handle is any kind of array you find out there, and it works exactly the same way. No object content, no object header about it, no object content around it. It just behaves like a long array. And it works for int arrays and whatever you want to. And the worst, it's byte array view. And to solve this 32-bit issue, I had a long discussion with Paul Sandos, one of the JVM engineers. And that is what my idea was, what this discussion could lead to. So you have a memory region, and this memory region can be 64-bit, and you say, I want to align memory, unalign, whatever. This name thing was just maybe make it available through JMX so people see that there's actually something going on. And then you create a view again. And I say that my view should look like a long array again, and now I have a... Yep.
Can you please tell me where is the memory for the size of the array? So you have like only 8 bits of memory for one long, and you're trying to access it like an array of long.
Yeah.
And an array is an object, and it must have some size.
Well, in this case, it has a size of 1, because you just have 8 bytes, which means you can store exactly 1 byte. So if you would store, if you would try to access the second index, it will throw an exception. It will do this. As I said, this is completely made up. That was my idea how to implement that. Unfortunately, it didn't happen that way. What we get now is we get a scope, so an auto-closable scope, pretty much the same thing as any kind of scope in the Java language. You use this scope to allocate memory, and in this case you have native library create layout, which will give you this long array-like layout, and you say number of elements. And you don't have to give it a byte size or anything. You just say, I want a long array and give me 20 elements, and in this case, the JVM can figure out, okay, you need 8 bytes per element, so, right, I just need 160 bytes in this case. And this is very interesting because allocate returns a pointer. Who thinks, or who thought that we ever get a class in Java which is called pointer, right? And it's getting better because this pointer interface has one private static, public static field. Who can guess what that is called? Null pointer. Perfect. So in the first time in the Java history, we actually have a chance to get a real null pointer exception. I find this very, very interesting. Okay, so we created our, well, native memory that looks like a long array, and then we say, okay, in the pointer, or from this base address stored in the pointer, please give me the 5th index, and this offset will return another pointer, obviously, right? It's like in C++. And then you dereference this pointer into a Java reference. Well, looks still like C++ code, so. And you can actually use this reference to a long. Hopefully in the near future with some other thing, it will be a primitive type long. And then you can just access it like every field, every value inside of Java. That's quite interesting. So you have a reference and a pointer class. So that is the new idea. And the thing is, since the scope is auto-closable, whenever you leave this try with resource block, it will automatically be deallocated, which is quite nice. So I already said this is somehow constantly changing, and that is very recent. This just came up, I think, 2 weeks ago, 3 weeks ago. What is it? Well, whatever, something like that. I love this tweet saying, pointers, references, memory regions, and using the word Java, and that in a tweet, it doesn't sound right to most of the people. So, deserialization, we already seen that, right? In this case, I've found another example, one that I did in the past. So there's a char array, we read this from a stream, and you use allocate instance on the string class to create a string instance without calling any kind of constructor, and then you just pass in this char array into the string instance, which makes you a valid string. There is a constructor which takes a char array as a parameter. Any kind of idea why I don't use that or why I don't want to use that? Because it makes a defensive copy. So I pass in the char array, and because char arrays or arrays in general are non-immutable objects, it will have to create a defensive copy to make sure that nobody is going to change the char array. If I read it from a stream in a deserialization process, there is no chance I will ever expose this char array in a different way than using this string. So it doesn't make sense to me to copy it. It's just a massive cost I try to avoid. There is one other way, and that is reflection factory. This thing already exists for a long time. This relies in sun.reflect. So another sun package. This time it's not sun.misc, but you can use the reflection factory, and you tell it, please create me a constructor for deserialization, which will create a default constructor which doesn't do anything. It doesn't matter if this constructor is existing in the bytecode or not, it will just do it for you. And the actual idea is just create or just move this to a public package. I think it's at the moment they think about Java Reflect, which kind of makes sense, or Java Lang Reflect, whatever it is. And to make this available to deserialization factories or deserialization libraries. So that would actually solve this issue for most of the cases. It's not as nice as not calling any kind of constructor, but it's still very decent. So we can work with that. And then we come again to the JNI. And unfortunately, there are not a lot of JNI developers here. Yesterday in Malaga, there was like 7 or 8 people agreeing with pretty much every line of the code that it is amazingly ugly. Did anybody work with JNI? Who understands this shit? Right? So this is everything, but not good-looking code. It's not nice. It's not even good-looking C++ code or C code, right? It's just ugly stuff. And then you have to make this load library thing, which kind of is weird because it says, okay, I have to have a static object or a DLL called process identifier, and well, hopefully all that works. And then you can just call get process ID if you have this native bound library. That's kind of a weird thing. So some people, like Charles Nutter again, for JRuby, he had to create something better. He had to, because JNI sucked and JNA sucked and everything that is out there sucked so far. So he created JNR, right? Java native runtime. And this thing is very interesting. You have an interface in Java that is what you want to call. So this is the specification of what you want to call. There are some pointer classes for those weird cases where you need pointers. And then you have this library loader create. You give it the instance of the interface. It will spin up an implementation at runtime. And you say load this to C, which is libc in Linux or glibc or whatever is out there. And then you just call it. The interesting thing is this line will do some assembler generation at runtime. It will actually spin up the JNI stuff at runtime, inject it into the process memory, and just calls it. That's pretty cool. Maybe not what Java developers call safe, but it works. And actually, starting from this JNR point, Java will become or will get a bit more like the foreign function interface stuff in most other languages. We're coming back to the method handles, but the method handles API will be extended by something which is called find native. You give it the name of the method, you give it an int type, you give it a library if you have to. This is the first parameter. In other cases, it will just use the standard library. And it will do the same thing. It will spin the assembler code at runtime. It will bind it. And the interesting thing is, since it's a native method handle, as we already had or said this, the JVM is free to inline this call to C++ or C code, which means it's quite interesting because the native call becomes part of Java itself. That's pretty cool because based on this, who knows what intrinsics are? Okay, just a few people. The idea behind intrinsics is you have Java code which works on all platforms, but on some platforms, CPUs might help you. They have special opcodes, and the intrinsics are part of this concept. So that means the JVM figures out, okay, I'm running on Solaris, on Itanium, on something special, 64-bit Itanium. So I know there's a very special CPU opcode doing this, or doing it better than the Java code. And instead of optimizing the Java code, I'll just emit this intrinsic. So you get optimized C++ or assembler code instead of the optimized Java code, which sometimes is interesting if you have a problem in especially that code, because you look at the Java code and it doesn't give you the idea of the problem, but the problem is there because you get this intrinsic stuff. But with that API, the JVM will actually get custom intrinsics. That means if you are a library developer, you can create your library in a way that it works on every platform. But if you are on this Solaris something thing, right? Solaris 64-bit Itanium or X64 or whatever, you can kick in your own intrinsics instead of the actual Java code to make your own code faster. So that is pretty nice. I already was talking about something which will make things in object representation better. And who heard about value types so far? Okay, that is a good number. Okay, so value types, Brian Gutz loves to refer this as codes like an object, but works like an int, or works like a primitive. So that means it will actually make a very concise object layout or memory layout. So you can imagine this as a two-element array, and it's actually stored right behind. And there is one more important thing. It will give you stack allocation. And this is where this thing is interesting. I'm not sure how many people know that Java already has stack allocation in very special cases. The special case is escape analysis. That means the JVM can figure out your object will never leave the method or the scope of the method. Therefore, I don't need to create it on the heap. I can just store the 2 or 3 elements, whatever it is, the 3 values, the 3 longs, ins, right in the stack of the method. So I don't need to store it somewhere else. With value types, you get this on user promise. So you say, I want to have this as a value type, and you can make it even better. You can return this value type from your method, and the JVM will make sure that all the content of this value type is copied with the standard Java regularities of copy value by copy, or copy by value, whatever it's called. So stack allocation is for a lot of Java developers in the very low latency, consistent latency sensitive area is very important, because it means you don't crash your cache lines, because you don't have this pointer indirection where you have to go through heap memory and stuff, but you can just work on the stack. For normal Java developers, it's probably not as cool as for me. The other thing, and that is, I guess, most interesting for a lot of Java developers, or for most of them, is specialized generics. Who knows what generics are? Who worked with generics? Who knows how generics work? Type erasure is, right? Okay. So type erasure is a big issue in Java, right? You can't have 2 interfaces implemented, or the same interface implemented twice with 2 different types, because type erasure would give you the same type in the method call. Big issue in Java. Can be solved with specialized generics. The idea is, imagine a specialized generic as a template. So we have a new keyword here. We can't see that, which is any. So it looks like a generic, but you say, okay, it can have any type of T. And that is where it's becoming interesting. So you have a set method which with an element of T, and a get method which will return it. So when I put in a string, it will behave like the normal generic so far, right? We have a string box, all good. Same for random class, but who is waiting for that? Right? Primitive generics, that's absolutely amazing. And the interesting thing here is that it won't do a void set integer, but it will do a void set int. So there's no auto-boxing, it actually is a primitive version of the box. So if your box has an array of t, it will actually be an int array, because it's a template and the JVM spins up the right implementation at runtime. So that means all this will work as expected, and in the first case, there is no boxing going on, which is absolutely amazing. I'm not sure who figured out that boxing can be a performance killer. Okay, that's good. I hoped at least at that number. I thought everybody was going to raise his hand. And there is some more cool things coming. We're coming back to the specified generics in a bit. So arrays 2.0, who heard about that so far? Okay. What is interesting on this line? Max value, right. So this is actually a 64-bit array. Who knows that arrays can have only a 32-bit index? Perfect. That was what I expect. So you can, with some new API, you can chop down an array, which is interesting. So when you shrink down your array, it actually works. No idea why it only works in this direction, but I think because they can reclaim memory and they don't need to allocate another one. Well, we have that, right? Does that work at the moment? Well, it compiles with a compiler warning that arrays are not generified or not generic, so you can't do this. It just looks weird to the compiler. But what is more important is this will work as well. So this is where the specialized generics come in. That means you create an array of a specialized type. So it's not a generified array anymore, it's an array of a specialized type. And that is interesting, because now I can do this. I know it's type safe, the compiler can check it, and there's still no boxing going on. That's pretty cool. This is another one. I'm not sure who figured out that this was already in one of the slides. Immutable arrays, what does Java have? Are Java arrays mutable? Yes? Perfect. What do you think does freeze do? It actually makes this array frozen state. That means it has an immutable array. And that is missing in Java forever. That is missing right from the first version when they created the arrays. You can actually make an immutable type of an array. That's cool. No defense copying going on anymore, because you can say, I don't want this array to be changed. And going back to the point class, nice value class, there's one more thing. I already talked about the stack allocation, but now we have an array, and we know that our value types is just the value itself. In this case, the x, y elements, and that means if I have an array, I just have one stack of, in this case, 3 elements, and they have x, y, x, y, x, y. No objects, no object header, just the pure data. Very, very neat. Okay, cleaner API. Who knows what the cleaner API is? Some people? Oh, even you guys don't know that? Come on, thanks. At least one. So the cleaner API is an implementation detail of the direct byte buffer. But everybody knows what a direct byte buffer is, right? Right? Byte buffer dot allocate direct. Perfect. So the problem is allocate direct allocates native memory using unsafe underneath. It doesn't matter how it does it. But it's a native memory thing. So it needs to be reclaimed. It needs to be freed at some point, right? And that is where the cleaner API comes in. This was so far the only real way in Java to make object deconstructors and finalization. Because we all know, who disagrees that you use finalize in standard Java code? Who disagrees with that? Perfect. So who disagrees that you use finalize in Java code? Good question, right? So we all know you're never supposed to use finalize because it's broken. So the cleaner API actually the cleaner is registered, and whenever the direct byte buffer becomes a phantom reference, the deallocator will reclaim the memory. This works whenever the garbage collector kicks in. In libraries like Netty, they actually ask the cleaner to clean at the point they actually want to. So in a very recent way, this becomes public API, just a recent commit. And the way it works is I just created some auto-cleaning class, which is auto-closable, so I can do this nice thing here. And I have a state, which in this case would store my memory address, my pointer, whatever it is. And I register myself to the cleaner, and either I close it myself and clean the memory, or whenever this thing becomes a phantom reference, it will automatically be done by the API, by the Java runtime. So that is a new public API, and probably the only real way of doing deconstruction in Java and of native libraries in Java in the near future. So we're running out of time, so we're just going quickly through the rest. There's some more exciting stuff. Class dynamic. We're going back to the templating function. So you can have a template going through all the different methods. So synchronized map would just be your original method, a synchronized block, and then call the underlying list, map, whatever it is. Synchronized map is probably not the best example, but I think that is kind of familiar to most people that actually work with aspect-oriented programming. You want to lock every method entrance and exit. And you just call the underlying method, and it will automatically be created by the JVM based on the template. You pass in a proxy, an object to the proxy, and it will actually create it. Whatever your use case is for aspect-oriented programming. Azul implementations on spin weight. Spin weight is often in a lot of CPUs is a special opcode, which will optimize the busy spinning. So if your CPU implements that, this is an intrinsic. If your CPU implements it, then your busy spin will be optimized away by the CPU. Otherwise, it's just an no-op operation. And a lot of other stuff is currently happening. There is so much stuff. If I would fill everything here in the slides, we could talk tomorrow still. So the important message with all of that, and this is where I'm going towards the Java 9, please try the Java 9 early access builds. Please do it. It's very important. If you heard about Jigsaw, the new module system, this is the most important thing before Java 9 comes out. Try your code, make issues at the bug tracker, tell the JVM team where it is broken or why your code doesn't work, and make sure that Java 9 builds will work whenever it's coming out. And with that, well, here are the different proposals. Feel free to download and read them, or just read these slides again and see if it makes sense for you.
Thank you for your talk. So how to free memory allocated by Unsafe?
Sorry, how?
How to free memory allocated by Unsafe.
How you free memory? Let me see. So the way you free memory is actually correct in that slide. You call unsafe free memory, but you're not supposed to call it on a Java object, because the Java object is obviously managed by the JVM runtime, by the garbage collector. So hopefully there's no real way to get the real memory address of an object in the Java heap. And even though you get the address, it might change in the next second when the garbage collector decides to move your object. So you're not supposed to do anything like that. But if you allocate your object itself or your memory itself using allocate memory, then you get the pointer, and this is where you free the memory with. Or this is what you free the memory with.
Small question. I am still unclear. Will traditional unsafe will it be completely removed in Java 8 or
unsafe?
Unsafe. I mean traditional unsafe. At the same time, these new cool features will be added.
Yeah. So the way it is supposed to work, or the way it will work, Whenever there's a replacement for one feature of unsafe, this feature will be marked deprecated and will be removed in the next version. That means if Java 9 becomes VarHandle API, all the memory access things in unsafe will become deprecated and will be removed in Java 10.
Okay, and can you quickly tell us what features of unsafe at this moment Hazelcast is used?
We're mostly using any kind of memory allocation and memory access features for our off-heap implementation.
And what is your roadmap? How you gonna accommodate new features?
Sorry, once again, what?
Do you have some roadmap how you gonna finish using traditional
Oh,
safe?
okay. So our migration path. So we haven't fully decided yet, but the way it will work, we have a memory manager API internally. This can already work with on-heap memory, with off-heap memory, and it will have a second off-heap implementation, which probably uses this pointer API when it becomes public. So it is probably just up to the Hazelcast instance at startup to decide what to use. If there's the pointer class or the reference class, then you know that you can use the new API. Otherwise, you need to fall back to unsafe, or in the worst case, fall back to byte buffers, something like that.
Okay, sorry, but we run out of time. You can ask your questions directly to the speaker at the coffee break.